All right, scientific notation is basically just a way to write really big numbers in a way that's a little bit more efficient. We have several ways to kind of look at big numbers. So standard form, you can kind of see over here, this would be standard form there, is just your normal number, so nothing new there. Product form, well, let me just rewind here. Scientific notation, the form, basically we are turning a number into, the first number has to be somewhere between 1 and 10. Between 1 and 10. No less than 1, and it can't be 10 or greater, okay? And so basically, if you see like product form, we turned that first number into one of those numbers that's between 1 and 10, 2.86, and multiplied it by a million because that's how like it would make it equal. Okay, so 2,860,000. Okay, these are all equal to each other. Scientific notation then uses exponents. Okay, so 10 to the 6th power is a million. All right, so I'm going to show you kind of an easy way to do this as well. Now this first example, probably not that hard to write, 6,300, but let's just keep it easy. So you probably wouldn't really use that for this number in scientific notation. So let me show you how you do this. 6,300, okay? Again, this first number here, like up here, we basically want to move the decimal so that we have a number that's between 1 and 10. So basically let's start here, okay? In this case, there is no decimal, so there's kind of like an invisible decimal at the end of the number, all right? If there is a decimal in a number, then that's where you start from. So in this case, it's at the end. 1, 2, 3 is where I'm going to go to because 6.3 is between 1 and 10. So my new number is 6.3. Now, to get it to equal the same thing, it's always going to be times 10 to the something, okay? And how we figure out what that something is we count the number of times we move the decimal. 1, 2, 3 times, okay? So if I would do that out, 6.3 times 10 to the 3rd, I would get right back to 6,300. It's just like a different way of writing a number, okay? So it's always going to be some number, okay, times some number that has to be between 1 and 10 times 10 to an exponent. That exponent will be determined by how many times we move the decimal. And again, we're moving the decimal to get it to a number that is between 1 and 10. So let's try this example. Okay, so I'm going to swoop my way over. 1, 2, 3, 4, 5 times, because 4.5 is between 1 and 10. So that's where I'm moving my decimal to. 4.5. We then count the number of swoops to determine our exponent. 1, 2, 3, 4, 5 swoops. So swoop over until your number that is between 1 and 10. So 1, 2, 3, 4, 631, not between 1 and 10. 63.1, not between 1 and 10. 6.31 is between 1 and 10. Now, the numbers you include are all non-ending zero numbers. So in this case, we're going to write 6.31 times 10 to the, and let's count the swoops, 1, 2, 3, 4, 5, to the 6. Include all non-zero numbers in your scientific notation form. All right, again, swooping over, 1, 2, 3, 4 swoops. Include all non-zero numbers times 10 to the 4th. Okay? Figuring the concept here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1 times 10 to the 10th. Get your number between 1 and 10, count the swoops. That's going to be your exponent, always times 10 to some exponent. Okay? 1, 2, 3, 4, 5, 6, 7, 8. Include all non-zero numbers. That would be 3.484 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8 times 10 to the 8th. Okay, so now when we go in reverse, the exponent is going to tell us how many swoops we need to move back the other direction. So I'm going to start at the decimal. If it's a number that doesn't have a decimal, it's just going to be at the end of the number, okay? And that's going to tell us how many swoops to go. 1, 2, 3, 4, 5, and we need to fill those swoops in with zeros. Okay, so that's how we get it back to standard form. Okay, in this particular example, okay, we start at the decimal, not at the end of the number, because it actually has a decimal. So we need to go 7 times. I'm going to rewrite this number here. I need to go 1, 2, 3, 4, 5, 6, 7 swoops based on that exponent. Fill in the zeros, and you got your standard form. Okay, I'm just going to do one more of these examples. Again, start at the decimal. Oops, start at the decimal. 1, 2, 3, 4. Fill it in. Okay. Here, there is no decimal, so we'll just make our own and start at the end. 1, 2, 3, 4, 5, 6, 7. Common mistake is people just want to add the amount of zeros as there are in the exponent. That doesn't work like for these examples, right? Because you have to start at the decimal. Okay, for this one it does, but I'm not going to add 10 zeros to this number because I have to cover 1, 2, 3 spots first and then go 4, 5, 6, 7, 8, 9, 10, and then add my zeros only to my blank spots. Hopefully that makes sense. Okay, so that's your final answer there. Exponent tells you how many swoops, or if you're kind of going in revert or to scientific notation, you swoop, that tells you your exponent. Okay.